So today we're going to be looking at the chain rule, the product rule, and the quotient rule. Let's start off with the chain rule. So let's say we're asked to find the derivative of f of x to the power of h. And to apply the chain rule, what you would do is the first step, just ignore the exponent and find the derivative of what's being raised to the power of the exponent. So in this case, find the derivative of f of x. Then for the second step, you would just basically ignore what's here, what's f of x, and just set this as any variable. So we can set this as the variable u, and then we will find the derivative of u to the h. And we can just use the power rule for that. And it's probably confusing since we're just using variables here. But we'll take a look at some problems and hopefully then you'll understand it better. So let's look at the problem, derivative of 2x squared minus 5 raised to the 5th. So the first step, just find the derivative of the value inside the parentheses, which is before x. And then next, basically, you would just move the 5 to the front using the power rule, multiplied by what's inside. Remember, we're ignoring the values of the numbers. We're just setting this as a variable. So 2x squared minus 5, that remains unchanged. And the 5 minus 1, with the power rule, you get 4. And this can be simplified to 20x multiplied by 2x squared minus 5 to the 4th. Let's look at another one. How about the derivative of 1 over the square root of 5t squared minus 3t plus 6. Well, this is, at first glance, it's not being raised to the power of anything, right? But actually, you can rewrite this as 5t squared minus 3t plus 6. And this is raised to the power of negative 1/2 because roots on the bottom is a negative fraction power. So we would apply the chain rule, find the derivative of what's inside. You get 10t minus 3. And then move the negative 1/2 to the front. And then the inside remains unchanged. And then negative 1/2 minus 1 is negative 3 to the second. And you probably should simplify that to 10t minus 3 negative because of the negative 1/2, and then 2 on the bottom, 2 ft squared minus 3t plus 6 to the power of 3, 2, because you moved it to the bottom, so we can eliminate that negative sign. Okay, so now let's take a look at the product rule. So if we are asked to find the derivative of a function f of x multiplied by the function g of x, the product rule is basically, it would be f of x multiplied by the derivative of g of x plus g of x times the derivative of f of x. Now let's look at some problems. Let's say we're asked to find the derivative of 3x to the 4th minus 7 multiplied by 2x cubed minus 6. So, you could just multiply this out and find the derivative, but that's probably too much extra work. So what you can do is just 3x to the 4th minus 7 multiplied by the derivative of 2x cubed minus 6. It's still a lot of work both ways, but we're here to talk about the product rule, not the derivatives of polynomials. Plus 2x cubed minus 6 to the derivative of 3x 4th minus 7. And yeah, as I said, it's probably still a lot of work to do it both ways. So we can simplify this. And the derivative, we use the power rule. We can just get 6x cubed plus 2x cubed minus 6 times 12x to the third. And then if we multiply this out, we get 18x to the 6 minus 42x squared plus 24x to the 6 minus 12 times 6. I'm doing calculus and I still can't do simple math. 72x cubed. And our final answer, these two can combine and we can get 42x to the 6 minus 72x to the third minus 42x squared. So let's take a look at another problem. Let's say we're asked to find the derivative of 4 plus x to the 9th times 2 minus x to the 5th. Well, here you notice that we have two quantities being multiplied each other, and they're both being raised to a power. So we can use both the product rule and the chain rule here. And how do we do this? Nothing really changes. Basically, we just apply the product rule, which is this times the derivative of this plus this times the derivative of that. So let's bring 4 plus x to the 9th down, and then to find the derivative of this, we can just use the power rule. So basically, the derivative of the inside quantity is -1, and then times 5 times 2 minus x to the 4th plus 2 minus x to the 5th, and now we have to find the derivative of this. So inside quantity, that derivative is 1 times 9, because we bring the 9 to the front. The inside remains unchanged. 9 minus 1 is 8. And this can be simplified to -5, 4 plus x to the 9th times 2 minus x to the 4th plus 2 minus x to the 5th times 9, 4 plus x. And this is the correct answer, but you can always simplify by multiplying, and I don't feel like doing that. Okay, finally let's talk about the quotient rule. Let's say we have to differentiate f of x divided by g of x. Using the quotient rule, we can rewrite this as g of x multiplied by f prime of x, and f prime of x just means the derivative f of x, minus f of x times g prime of x, so the derivative of g of x. That's all divided by g of x squared. So let's take a look at our problem. Let's say we are asked to find the derivative of x to the 4th plus 3x squared minus 6 divided by x squared plus 1. Using the quotient rule, we can rewrite this as g of x, which is x squared plus 1, multiplied by the derivative of the numerator, f of x, and I'm just going to do this in my head to save some space, which is 4x to the 3rd plus 6x minus f of x, which is x to the 4th plus 3x squared minus 6, multiplied by the derivative of x squared plus 1, which is just 2x. That's all divided by x squared plus 1 squared, which is x to the 4th plus 2x squared plus 1. Okay, so now let's distribute these two. So we get 4x to the 5th plus 6x to the 3rd plus 4x to the 3rd plus 6x minus 2x to the 5th plus 6x to the 3rd minus 12x divided by x to the 4th plus 2x squared plus 1. And then now we can distribute this negative sign. We get, I'm just going to write this part. Actually, we can combine these two terms to get 10x cubed plus 6x minus 2x to the 5th. Distributing the negative sign, we get minus 6x to the 3rd plus 12x divided by x to the 4th plus 2x squared plus 1. And now we just need to combine like terms. So 4x to the 5th minus 2x to the 5th is 2x to the 5th. Plus 10x to the 3rd minus 6x to the 3rd is 4x to the 3rd. And 6x plus 12x is 18x. And that's plus 18x. That's divided by x to the 4th plus 2x squared plus 1. And that's your final answer. Okay, so let's take a look at one final problem that uses both the quotient rule and the chain rule. So let's say we're asked to find the derivative of x to the 4th divided by the square root of x squared plus 4. We can rewrite this as the derivative of x to the 4th divided by x squared plus 4 to the 1/2 power. Okay, now using the quotient rule, we can write this as x squared plus 4 to the 1/2 power times the derivative of x4, which is just 4x to the third, minus x4 times the derivative of x squared plus 4 to the 1/2 power. Using the chain rule, we can write this as 2x times 1/2 times x squared plus 4 times to the negative 1/2 power. That's all divided by x squared plus 4 to the 1/2 power to the second power, which is x squared plus 4. Okay, so now we can just write this as 4x to the third times x squared plus 4 to the 1/2 minus, okay, 2x times 1/2 is just x times x to the fourth is x to the fifth times x2 plus 4 to the negative 1/2 power divided by x squared plus 4. And this we can just rewrite as 4x to the third times x squared plus 4 to the 1/2 power divided by x squared plus 4 minus x to the fifth times x2 plus 4 to the negative 1/2 power divided by x squared plus 4. Now we just bring this quantity to the bottom, making it 4x to the third divided by x squared plus 4 times x squared plus 4 to the negative 1/2 power. And then we do the same for this, so x fifth divided by x squared plus 4 times x squared plus 4 to the 1/2 power. Okay, so this is basically to the first power, and this is the first power. And we know when we multiply exponents, we add. So this becomes 4x to the third times x squared plus 4 to the 1/2 power minus x to the fifth divided by x squared plus 4 to the 3/2 power, because 1 plus 1/2 is 3/2. Okay, so now we need to subtract and to find a common denominator, and the common denominator would just be x squared plus 4 to the 3/2 power. And to get this, we just multiply this side by x squared plus 4 to the 1/2 power, and this by x squared plus 4 to the 1/2 power. So, and we get 4x squared times x squared plus 4. Sorry, not to the 1/2 power, just x squared plus 4, because 1 plus 1/2 is 3/2. And that would be x squared plus 4 to the 3/2 minus, and this side is unchanged, so x fifth times x squared plus 4 to the 3/2 power. And now we get 4x third to x squared plus 4 minus x to the fifth divided by x squared plus 4 to the 3/2 power. And we can distribute this to get 4x to the fifth plus 16x to the third minus x to the fifth divided by x squared plus 4 to the 3/2 power. And finally, after combining like terms, you get 3x to the fifth plus 16x to the third divided by x squared plus 4 to the 3/2 power.